All right, students, let me try another solution for you. This one's number 22 out of chapter 3. And again, it's kind of this trying to get to understand these vectors. So it's kind of before you get to the projectile motion. And it's a lot like the one I did in class. In class, we had a three-sided plot of land. It looks like this is a four-sided. It says a farmer wants to fence off his four-sided plot of a flat land. He measures the first three sides as shown in A, B, and C. So here's the A, and they give an angle and a distance. Here's B, an angle and a distance. And here's C, an angle and a distance. Okay. So he measures off the first four sides, and shown in the figure. Then he correctly calculates the length and the orientation of the fourth side, D. What is the result? And the idea being we're going to be adding vectors. These are position vectors, but if you draw them head to tail, head to tail, head to tail, and then the last one head to tail, and you end up back where you started, because the result of these four is to draw, and I'll draw maybe four that don't end up back where you started. The results, which I've been drawing in red, go from the beginning of the first to the end of the last. And if they come all the way back to itself, that distance is 0. And so that's why they say vector A plus vector B, C, and D then give you a total of 0. And of course, we've got to put x's with x's and y's with y's. So that means the x component of A and the x component of B and the x component of C and the x component of D must be 0. But it also means that the y component of A and the y component of B and the y component of C and the y component of D also have to come out to be 0. So they all have to come out to be 0. And they give us enough information to find the x components of A, B, and C and the x component of, the y components of A, B, and C. And so D then would be left over to find both the x and y component. In fact, you can see vector D. It looks like it goes down and left, so these should be each negative. Down is negative, so that should be a negative, and then left is negative, so that should be negative. All right, so let's start this problem maybe by pointing out that if I were to maybe draw a triangle in green here for vector A, the x component would be adjacent to this 7.5 degrees. So 7.5 degrees would be AX over its magnitude of 4.7. And sine of 7.5 degrees would be AY, although maybe I better put magnitude, because if you look at A, it goes right, so that's positive, so I didn't worry about that. But then it goes down, and so it's technically a negative number, but we're dealing with lengths and stuff, where in our trig functions, we just do absolute value here. So that means I could get AX and AY fairly easy by saying cosine of 7.5 and then multiplying it by 4.7 and come up with 4.66. Whereas y would be the sine of 7.5 and then that multiplied by the 4.7 length. And so the absolute value would be 0.613. So I'm going to put a negative 0.613. And again, because it goes down, so it goes to the right, so positive on the x, and then down, so negative on the y. All right, let me play that same game with vector B. And maybe I'll do a black color so it stands out, but I'm going to look at B as going up and then a little left. So the left means the x component is negative, and the up means the y component is positive. And it looks like there's a little, well, I kind of covered it, but that was 16 degrees there. And that means if I look at cosine of 16 degrees, the adjacent is actually the y component. So this would be by over its magnitude. Oh, I better make sure these are the same units. Okay, they are good. Just in case it wasn't a fast one, pulled on me with kilometers and then meters over here or centimeters over here. All right, so then this would be by over 2.48. And sine of 16 degrees would be, I guess I'll do the magnitude of bx over 2.48. Because again, that's going to be a negative number. So there gives me my by and my bx. And by the way, did you notice? It's worth repeating because in your standard trig class, you always measured angles, or maybe not always, but many times measured the angle from the x-axis, which meant that the adjacent piece was the x, and so you might have been associating the x with the cosine, and the opposite component would be associated with the sine, because that's what you get when you measure the angle from the x-axis. But when you switch that role and you start measuring from the vertical, like this 16 is, then the adjacent one is actually the y component. And the opposite one is the x component. So I think sometimes when students enter this class, they come in with the notion that if you want the x component, you use cosine. And that's not quite right. You use the x component, or you use cosine when you want the x component if it's measured from the x-axis. But that role gets reversed if you're measuring from the vertical axis. So cosine always means adjacent, and that's the better way to think of it, adjacent. Because measuring from the vertical, adjacent is the y-axis, or the y component. And then if the angle's measured from the x-axis, then the adjacent is the x-axis. And that's the most common way you've seen it. And that's how you treat beginning students. But, you know, you're not beginning anymore. You've had trigonometry a long time ago. All right, so with that in mind, you'll see that the sine and cosine might be the reverse of what you thought they would be. Because you've always been measuring from the x-axis like we did for A, but for B it's reversed. All right, so let me take the cosine of 16 degrees and multiply it by 2.48 and come up with 2.38. And for the x component, let me go sine of 16 and multiply that by 2.48. And gets 0.684. And emphasize negative, because this was the absolute value, and as I said earlier, it's B is up, so positive y, and left, negative x. Okay, well, let's keep going here. Let's look at C. Maybe we'll need to come to the picture. I'll just kind of fold it here. But C looks like it is left and up. So the left would mean the x is negative, and the up would mean the y is positive. And if I make a little triangle, let's see, it's a different color. How about blue? Okay, so for the x, I'd come over and up. And that 19 degrees that I just covered up, if I go cosine of 19 degrees, I would get the adjacent, so that would be CX, and I'll just say it's absolute value, because again, I already said it's to the left, so it's really a negative number, and I'll throw that in a moment. And then over its hypotenuse, 3.02. Whereas the sine of 19 degrees is CY over 3.02. And by the way, notice we are now measuring from the x-axis, from the horizontal. And so the part that I just got done saying, how you're kind of used to getting the x-axis from the cosine function and the y component from the sine function. And that works when you're measuring from the horizontal, from the x-axis, which we did in A, but not in B, so they reversed in B. And now we are back to the x-axis here in C. All right, so grabbing the calculator here, cosine of 19 degrees times 3.02 comes out to be 2.86. And again, let me throw in that negative there because, as we can see in the picture, the x component is to the left. Now, the y component is upward. Okay, so this would be sine of 19 and 3.02. And so that's a 0.983. And it is a positive. Okay, so we've got all the pieces to our earlier discussion that said the x's all have to add up to 0. So let me start then with ax. So 4.66 for ax. Bx, so I'll just go plus a negative, 0.684. And cx, so plus a negative, 2.86, plus d in the x direction must come out to be 0, allowing me to solve for dx. And as we can see in the picture, d is down and left. So the left should indicate that I'm going to get a negative for the x component. And the down would indicate I'd get a negative for the y component. All right, so grabbing my calculator, 4.66 minus 0.684 minus 2.86 gives me a positive on this side of the equation, 1.16, and I'll move it to the other side so it becomes a negative 1.12, and we've been doing things in kilometers. So there is the x component of d, and let's do that with the y. So I'm going to take the y1, which is negative 0.613. I'll add it to the by. I will then add it to the cy, and then dy should give me 0. So that should allow me to calculate dy. So this first one should be a negative 0.613, then a plus 2.38, then a plus 983, and that is a positive 2.75, which when I bring to the other side is going to be a negative 2.75. And again, we've been doing everything in kilometers. All right, so there are the components, and I've got the down, so there's the negative y, and then the left, and there's the left. And so the total magnitude of d squared, Pythagorean theorem, is the 1.12 squared and the 2.75 squared. And I just dropped the negative because I'm squaring it. So to get d, I got the 1.12, and I'll square it. And then the 2.75 and square it. I'll hit enter, then I will take the square root and say that this last fence d needs to be 2.97 kilometers long. And they did say the orientation, so let's see, what angle do they want? They want this one. So I'm going to take my x and y and then use the trig function tangent. Now remember, tangent means opposite. And in this case, opposite is the x. So dx over the adjacent dy. And maybe this is worth mentioning it again like I did for vector b. I know you're kind of used to, from your trig class, associating the cosine function with x. But like I said, that does work when you're measuring from the x-axis, the horizontal. But when you measure from the vertical, the y-axis, they switch roles. Same thing can be said about the tangent function. You're probably used to thinking of the tangent function as the y over the x, but it really means opposite over adjacent. Now, it turns out to be y over x if you do the standard measurement from the x-axis or the horizontal axis, but that's not what's going on here. They're giving an angle from the vertical, so the x and y are going to switch roles. And so the opposite of here is the x component, and the adjacent to it is the y-axis. Okay, so to get this angle, I guess the first thing I would do is go inverse tangent. And I'm going to take the inverse tangent of both sides. That's why it gets rid of the tangent function, so I just have a theta. And then I'll have the dx. And I should have said I was doing like a triangle, so it's its magnitude. Okay, so how long is it? 1.12. And then divided by 2.75. And I get an angle of, this is a terrible time to check if I'm in degrees. I am, okay. I am at 22.2 degrees. All right, hope that helped.